Eccoci live.
Okay. Hello, everybody. Welcome to
afternoon.
this live chat. Today we are going to talk about a very interesting topic, a topic that we had to study in the last few months in our company, and that we wanted to share with you. And for this reason, we also invited an expert on this topic. Please welcome Luca Baggi. Luca is a machine learning engineer in Extreme. He deals with a lot of different topics, from large language modelings to data processing and time series forecasting, and has been working a lot with the library we want to discuss today, which is Polars. And if you haven't heard about Polars, even better, because you might learn something from this live stream. And Luca is also a maintainer of FunkTime AI, which is a library which is based on Polar. So welcome, Luca.
Thank you very much, Luca. It's a real pleasure to be here.
And I prepared just a couple of slides to just give some guidelines about the conversation we're going to have today. It's going to be a very informal chat, but I wanted to just start with some material, because today we are going to talk about a very specific library, which is Polars. And it's a library that a lot of people have been talking about recently. It's gaining a lot of popularity. I believe the title is a bit misleading, because you can read the experts in plural. Actually, I'm not an expert of Polars. I'm just a student of Polars, but I believe Luca is an expert of Polars. So at least we do have one expert in this fireside chat. But what is Polars? Polars is a library for data frames. If we look at the payoff of Polars, it's defined as a blazingly fast data frame library. It's a very bold and strong statement, blazingly fast. I believe it's true. And it wants to be an alternative to pandas. So probably you already heard or worked with pandas in the past. You might be aware of the limitations of pandas, mostly from a computational point of view. And Polars wants to be a fast data frame library. And the main reason why it's so fast is that it's written in Rust, which is another up-and-coming programming language that allows to make use of computational resources very efficiently. So if you are working on a single machine, it allows you to use all the CPUs, all the parallel cores of this machine very efficiently. And it also makes use of a very interesting concept, which is the concept of lazy frames. And I believe, correct me if I'm wrong, Luca, Polars was created in 2020.
Yes, I think right, Richie, the maintainer, creator, and also co-founder of the company behind it right now, started during the COVID or pandemic time. So for sure, 2021. I think, if I'm not mistaken, should be 2020 as well.
And yeah, you mentioned that the creator of Polar is Dutch, so we can say it's a European library.
Yes.
It's also something very important, like when we have good initiatives and great initiatives coming from Europe. I also feel happier to share about this kind of developments. And I believe now they're also they created a company behind the Polars.
Yes, exactly. I think it's Polars, the company, is also hiring. I do not represent them in any way, shape, or form, despite just wearing a bit of their merch. But they're really hiring talented Rust developers, not only to work on Polars as core, but also Polars, the product they're going to build.
Which is, yeah, it's also great, because it means that it's a library that is going to be maintained quite a lot in the coming months and years, because as we will see later on, it's we believe that it's here to stay. And today we are not going to dig into the details about why Polars is so fast. Maybe I'm not a software engineer, so for me, I see Polars as a product that I use. I'm very happy it's fast. I don't completely understand what's going on inside. Maybe Luca understands the inner working of Polars a bit more. But as I was saying, one of the concepts that I liked about this library, which also makes it so different from Pandas, is the concept of lazy frame. Because in Pandas, you might be using to working in this opposite mode, which is the eager mode. So every time you run a line of code in Pandas, it executes all the operations that are described in that line. And this lazy execution is a completely different philosophy. So here we just included a snippet of how it works. When you create a lazy frame, you basically collect a number of queries that you are going to apply to this data frame. But these queries are not executed when you declare them. So they're executed in a moment where you decide to collect, like with this command collect, to collect all the operations that you declared so far. So that is the moment when all the hardcore stuff happens. And the great thing about this kind of syntax is that under the hood in its engine, Polars decides what's the best way, the most efficient way to perform these operations. So you might, for example, in this snippet, I'm reading a Parquet file, scanning a Parquet file. So I'm creating this kind of this lazy frame, and I'm telling to filter only columns associated to a certain week number and a certain day of the week. So inside it will do this operation. I'm telling to aggregate, to group these columns by an hour of the day, and to collect an aggregate information about this data frame. And all these operations are happening when I call this collect function. And the great thing, in my opinion, is that you don't have to be super efficient in writing this kind of queries, because Polars does everything under the hood. And for me, it's like a black magic, because I really see that it's really fast. Maybe Luca knows a bit more about what there is something behind it that makes it so efficient. But it is it. And the most important is that it also allows you to work with large in-memory data, which is something that can be very problematic with Pandas. And this is all very interesting. I think it's something that differentiates Polars a lot compared to Pandas. In Polars, you can still use the normal eager mode, so you can also have a way of using it as you would use Pandas. And of course, it's a completely different API. It's a more modern API because it's more recent. I don't know if, Luca, you're used to using both ways of Polars, or you're more of a lazy frame user.
Oh, well, that's a really cool question. Up until version 1.0, so the short answer is I've always used lazy mode, because it's just so fast that it doesn't really matter, and it's really interchangeable. So at any point in time when you're writing some Polars code, whether you are in lazy frame mode or in eager mode, you can always switch from one to the other without having to change your syntax. It just, in this case, for example, you have to call collect, but if you had like a data frame, you could always cast it to eager, actually to lazy, to make it lazy. So interoperation is really fast, and you don't need. It's really easy to go on and on. Before version 1.0, you had a method called .fetch, which I think was removed in version 1.0, which kind of worked as a debug statement. We made no guarantees that the data that was returned was going to be the shape, for example, that the size they were meant to have, but it was good to debug statement here and there. But I mean, unless you're really working with huge data, huge quantities of data, then it's just really easy to work with any of those. But it's really easy just to get started and work with lazy frames from scratch. You can always just call .head somewhere. Beware that when you call .collect, of course, you will have to materialize the whole operation if you haven't before.
Yeah, that's super interesting. And I also wanted to add that as Pandas Polars, it's really easy to install. You can install it using a pip install Polars. I would say it's an alternative to Pandas, because it does the same things you would do with Pandas. So it's really designed to work on a single machine. So it's not a distributed engine like Spark. It's something that really allows you to do stuff that you would do in Pandas. And do you see it the same way, Luca? Is an alternative to Pandas? And
So yeah, the other day I was talking with a data science colleague of mine. It was like, when would you recommend pandas over polars? And he was like, did I get your answer correctly? And I was like, yes, because I know there are many reasons to choose polars over pandas, but when would you do the opposite? And suppose you have on a scale like from 1 to 100, I think that polars can bring you from, pandas could bring you from 0 to 30, 40, or 50. With polars, you could go from maybe 5 to 80 or 85, whereas the rest is just data frames like Spark and distributed systems. And I say that polars doesn't start from 0 just for a couple of reasons. The first one is maybe with pandas you can read some exotic formats such as SPSS or Stata or even Excel in a way. You can also do that with polars using Calamine, which is an incredibly fast Excel library, parsing library written in Rust. But it's maybe not top notch. So maybe some workflows that you use pandas with to read Excel files, just in terms of scale, but also in terms of API, are not as easily handled by polars. And the second thing is documentation. There are plenty more resources about pandas, though I would say this is by far the least concern. The documentation is polars is great. There are many people, incredibly good people talking about it. So especially now that polars is stable and it's reached like a 1.0, I think that they're basically overlapped, and polars can bring you so far ahead, especially when it comes to getting into production to work with it. For example, just one minor thing to wrap this up. I was talking with a friend and it was like, yes, we're using pandas for data analytics, but then when we move to production and we try to train, for example, a k-means model, we just cast everything to NumPy and we do the aggregation with NumPy because it's just faster than pandas. Nowadays, like, I wouldn't ever recommend doing this. It just use Polar from scratch, and then you can seamlessly translate from development to production.
Yeah, it's also an interesting aspect about the interoperability of this library, because it's true that because of its age, polars might not have the all the functions, all the functionalities that are there in Pandas or other libraries, but you can always interoperate between different libraries by transforming a polars data frame into a pandas data frame. Of course, it makes things a bit more.
You're correct. Though I would try to make a point. So the first layer of interoperability comes from Apache Arrow, which is a common in memory. It's just a standard to represent data into memory, i.e. in your RAM on your machine. And polars leverages Arrow. So interoperability between every project that is Arrow compliant is mostly 0 copies. So when you cast from one project that is compatible to Arrow to another, basically you don't need to create copies of the objects even across different languages that use the same protocol. So that's on the one side. But I would say that on the other side, the polars API is really extensive, and I still have to find a method that polars the pandas has that polars doesn't. I would say that for more for the stuff that you will regularly do, you won't miss pandas for that, because the feature has been built into polars. Even exponential weighted averages, for example, are there. I would actually make the point that polars has many more options to work with data that pandas doesn't have. And as a fact, most people come from polars for the syntax, for the speed, but end up staying for the syntax. And I would say that polar syntax is just so much more elegant in a way, and then people just stick with that. But it also has features that reproducing with pandas will take a lot longer to work with. For example, you can use window functions in polars. You can create and aggregate something over something else. That in pandas requires an aggregation and a join operation. So that might just be it's more handy, right? You have to do it in 2 steps. And then another amazing feature that Polars has is that you can natively work with exceptional level of performance on array structure and nested data structure. So, for example, columns that contain dictionaries, which is something that in pandas would require you to just to blindly apply str.get method, which isn't documented but works also on dictionary because it just tries to find that method, or otherwise just use the really infamous .apply method that basically just runs a for loop on the whole column, so you lose out on the benefits that you might have.
Yeah, yeah, that's a very interesting point, and I think we have been aware of Pandas's limitations for a few years now. There have been a number of libraries that try to overcome these limitations. Remember Vaex, Modin. Every now and then there was a library popping up claiming that it would be the new Pandas. And of course, there's always the point: should I learn this new syntax? Should I learn this new how to use this new library when Pandas is so common and commonly used? What really pushed me to give Polars a try was I really noticed the immediate increase of popularity. So in this graph that comes from I think the website of Polars, you can see that within 2 years of span, the number of stars on GitHub really started growing exponentially. And this is a fairly old graph. So it's from August 2023, so almost 1 year ago. Right now, I think they reached almost 30,000 stars. So it's maintaining the same exponential behavior. And from this graph, you can really see that this is not like the others library I mentioned before, or Vaex or Modin. Like, there is really a community building up, and that means that there's a lot of interactions also between development team and users. And recently we were both Luke and I at PyCon Italy, and you could really hear the buzz around Polars because first of all, many talks were about Polars, like Luca himself presented a talk about Polars, but you could really hear a lot of people talking about it, and that's something that I feel never happened with other Pandas alternatives, and it gives really a good sign that Polars is here to stay. I don't know. Probably, of course, you think the same because you are the Polars expert, but
trying to make up.
You can really feel the vibe around this library nowadays, and it's this means that even if it takes a little bit of effort to learn this new syntax, this new API, is something that it's really worth it in the future. And I don't know how it was for you. Look at this kind of learning curve, because of course you have to forget what you've learned and start from not from scratch, but you have to adopt a new philosophy when you process data, when you use Polars.
So I totally agree with you. Just one point, Pandas has done an excellent work, and all these alternatives are amazing, but some are maybe not maintained anymore or appropriate. And in a way, yes, some things that Pandas has don't apply to Polars. For example, the square bracketing to access columns is not like a good practice unless you want to extract one column because you're an end of a pipeline. For example, you need to cast that to an NumPy array or something. But in a way, I would argue that Polars is just much more natural. Okay, it takes like the modern Pandas syntax, because Pandas now has a .assign method and a bunch of other, they just call it like functional method that do a lot of function piping and method chaining, and took it to the next level. And in a way, it freed itself from having to be compliant with PandaSpec to get rid of all the idiosyncrasies and adapt to and come up with a new DSL, or domain-specific language, or a query language that is superior in any way, shape, or form. And I'm really bullish on the Bear because it's really an incredible library. And as you're showing here, its popularity growth is staggering, even compared to an equally valid project, which is DuckDB, which is basically just Polar with a SQL first interface. And they're also European as well. They come from, I think, Belgium, if I'm not mistaken. So DuckDB is another amazing project that is gaining a lot of traction. Polars is younger, and it also its adoption rate, if you look at the PyPy numbers, are incredible. It surpassed, I think, 30 million downloads. I'm not sure, should double check, don't quote me on that, but it's definitely here to stay. And I'm really bullish on Polars because it's an incredible library. Some queries, even just because even compared to something like DuckDB, when it comes to some expression that you want to write out in SQL, it's just much more handier to write than in using Python in a Pythonic syntax, because some operation, aggregation, rolling functions are just much more concise. So in a way, it's just something that takes a bit to learn, but in the end, I think it's once you get into it, and it doesn't take a lot of time. I would argue it's super easy to learn, and it will come much more natural because it doesn't have all the idiosyncrasies that Pandas has. For example, the Pandas has a dot filter method which selects the columns, not the rows, which is really non-intuitive if you come from even from a SQL background.
Yeah, yeah, yeah. That's really interesting. And I think you also mentioned that when you were talking earlier on that the syntax is changing. Like there's different versions, different releases. I think the releases are quite frequent, but we reached a couple of weeks ago a milestone, which is Polars 1.0, and which is probably the most important milestone so far, because what they claim is that first of all, we had a lot of maybe growing pains. Like of course the syntax is going to since it's a fairly young library, it's going to change and be adapted and optimized, because there's still time to make things the way they should be. So with this release, what the developers and the maintainers are saying is that we now have a production ready engine and API. So it means that maybe with this release we had some breaking changes. I don't know how big these breaking changes were, to be honest, but the idea is that from now on these breaking changes will happen less and less frequently. And they also mentioned that they added the GPU support. I'm not very familiar with this new implementation. I don't know, Luca, if you have any insights, information about this 1.0 release, and if you think it's really true that from now on updating Polars won't really cause so much pain as it.
So yeah, I think that they are pretty serious with that. One other thing that I forgot to mention is that Polars really has an awesome community. Richie and all the other maintainers are really open, so you can always come up with an issue, open it, make it reproducible, or just ask for a feature and it will be implemented like most of the time. So engage with them if you find there's something isn't there. The Discord is really open, and I think it's one of the healthiest community, maybe between Python and Rust. It's really great in that, and they're really serious about their commitments. That's what I got, the vibe I got from there, and I think they're pretty serious with breaking changes. Most of the broken stuff that happened in 1.0, there were some that were unannounced, but most of it were the deprecation that have been notified since late whole point 20 or 20, I don't remember, the minor version that came before it. So a lot of stuff broke, especially in the open source project that I maintain. And the 0.20 series was really like frequent changes and frequent like updates coming out every week or so. There was one day we had 2 releases on the same day, but even though the frequency of updates won't slow down, they're pretty serious about the breaking changes, and they won't happen. So I kind of expect that we won't see Polar Supernova coming soon. We won't see breaking changes in the public API. Maybe there will be some, but they will be thoroughly advertised, and it has reached a level of maturity that make it safer to use in production. Speaking of GPU support, though, And what's missing in this latest release that we might want to see in the future, the streaming engine. You mentioned that Polars can work with bigger than memory data, and that's something that we as Extreme used quite successfully in a product that actually saved us in a deployment that was supposed to use pandas, and then Polars like just solved the problem completely. However, the streaming engine isn't, I wouldn't say production ready, but they don't consider it feature complete. And actually, it's being rewritten as we speak. So in the future 1.2, 3, whatever releases, we will see a new streaming engine, more efficient, more complete. There isn't the switching from an eager, actually, sorry, not an eager, the default backend, which is stable, to the streaming and GPU backends is really easy. You just change a keyword argument in collect, in the collect method. This streaming engine has worked for most of use cases, but sometimes it breaks. And Polars, unlike DuckDB, doesn't strive to get the lowest memory consumption, but it just strives to utilize your RAM as fully as possible. So compared to DuckDB, which is also a streaming engine, you might see the memory usage skyrocket somehow compared especially to DuckDB. But still, you can use the Polar Streaming engine. Right now, it won't be as feature complete as the regular engine, but still it can be used quite successfully. And I think you also used it in production, I assume, right? Without much of a hassle.
Yeah, for
And,
sure.
and the GPU support, and then I think we can move over, is a really niche thing. I think that I mean, sometimes CUDA or like NVIDIA says, okay, we built Rapids AI, we have QGF, you can just one line of code, change your pandas code and make it run on GPU. But they forget that you have to have the price tag attached to it because you need to buy a GPU. But still, it's an incredible feat, and that GPU support is basically the same. The NVIDIA people came to the Polish people and said, okay, we can just work together. And basically, the idea for this engine, which is still experimental, but I think will kick soon, is that the Polars engine will be able to understand and seamlessly interchange the query plan to a GPU, which will be able to run basically all the coding, all the data processing steps on the GPU, and potentially send back some data to the CPU, where Polars will do all the handling of all the query engine optimizations. So it will allow you to seamlessly use both of them, for example, if you're working with those. I wouldn't bet on that being, for example, something that can work multi-GPU. I'm not an expert of that field, but it's still good to have that because in a way, maybe if you're like in the 10% or maybe 5% of the use cases that require that, it's good to see that at least you have an alternative to the QDF or pandas-like syntax and all of its kinkiness.
Yeah, it's for sure nice to have. It's and today I think the idea of this chat was also to talk about the fact that Polars is indeed production ready. So also to share some of the work we are carrying out with Polars. And so maybe I prepared a couple of slides just to talk about a couple of projects on our side, but then I will also be happy to hear from Luca how they are using Polars in Extreme, because that's the way we came into, we were forced to start experimenting with Polars basically. A few months ago, less than 1 year ago, we started working, we do work with synthetic data generation. So we do generate artificial but realistic data. And we work a lot in the financial field. So we work a lot with data describing transactions of people over time, just bank transactions or card transactions. And of course, these are huge data sets because they might contain literally billions of entries. And it means that we are really talking about terabytes and terabytes of data. And for this particular project, it was transactions coming from the US. It was a very large data set. And we really needed to do a lot of data exploration because we really need to understand the data we were working with from a statistical point of view. So understanding what were the consumer behaviors in different states and cities and different times of the day. But this data was huge. So of course, pandas was not an option. our only option would have been using some distributed engine like PySpark or maybe working servers in a serverless way on AWS, for example, with Glue. But it adds a layer of complexity that we really didn't want to have at the beginning when we're really doing some data exploration. And that's what really drove us to Polars, because it actually allows us to use a different option. So start working on our own single machines, and it did work. So with these lazy data frames, we were able to process billions of transactions, because we didn't really need the information coming from every single of the transaction or every column in the database. But with the lazy evaluation, we could really extract only the information we wanted from this engine, and it literally allows us to work on our own machines, maybe not on my laptop, but on my workstation that had a decent amount of RAM, which was something that if we didn't find Polars, we would not have been able to do. And that was some very, so almost a revelation moment for us, because it did work. It did allow us to do some data exploration and data preparation. And eventually, we also managed to use it also in production, because we use the same library to work on cloud, of course, on our deployment pipelines. But the same code that would be running on our computers was easily deployed on a large scale environment, because it's really very transferable in terms of deployment pipeline. And that was something that really demonstrated to us that it was really not just some kind of projects from the Ants project about making a more efficient version of Pandas and making it work, but it was something that was really suitable for a production ready project. And that's why that was what opened the floodgates for us. Like, we really become very excited about Polars. We decided that okay, we need to use it not just for this project, but we need to refactor a lot of our code, because it was really a way to make it more scalable. So, for example, right now we're working on implementing Polars within a machine learning preprocessing library we are working on. As you may know, machine learning models need some degree of data preparation, so making the raw data compatible with what the model will finally ingest as an input. So, for example, if you have categorical columns, you might want to do some processing like one-hot encoding, or if you have datetime columns, you might want to convert these dates in categorical features. And these transformations can be quite heavy. So usually, if you work with toy data sets, it's something that you can easily do with scikit-learn. There are a lot of libraries in scikit-learn that can do it quite efficiently. But when you're working with production data, which means that you might be working with databases with millions, if not billions of rows, this kind of libraries based on pipelines based on scikit-learn, for example, don't really hold. They really break. You really need to spend a lot of effort in terms of making it scalable, maybe from a distributed computing point of view. So right now we are working with this, a colleague of mine, Dario, is working mostly on this preprocessing library, which basically wants to be a machine learning data preparation library written in Polars instead of scikit-learn. And we are really excited about this project, because we really feel like it can really make a difference when you're really working with large scale data, and not just with toy data sets as we might be used in machine learning. And this is, for example, an open source project we want to work on in the coming months, and something I wanted to share today, because to demonstrate that yes, it's ready to work at a production level. And I know, Luca, that you are also working a lot on a library in particular, because you also presented about it at PyCon, this FunkTime, and I just wanted to ask you, maybe like we can close the slides right now to share a bit more about this library and about how you're using Polars to, if I remember correctly, do time series forecasting.
Yeah, so incredibly exciting projects. I have a couple of points to add, especially on the penultimate slides that you had, but still, we can do that a bit later. Coming to your question, yes, I'm a maintainer of an open source project named FunkTime, which is a library for time series forecasting at scale, which means for a panel dataset where you have more than one time series at once. And that is not production ready, I'm afraid to say, but it's an incredibly exciting project that I inherited from an incredibly clever guy, Christopher, who's now a founder of a Y Combinator startup. And he's a really like expert in forecasting. And he realized, and I totally agree with this philosophy of his, that polars, and especially time series, is the perfect use case for polars. And if you think about it, time series preprocessing, it's really all about applying the same operation and feature extraction all at once. And especially when it comes to forecasting, the research has shown us, and forecasting competition, you have to take it into account some way. You might not realize that you're just like real world example of that. But still, if you look at forecasting competition, you realize that feature extraction has played an incredible role. And if you look at the literature, you realize that gradient boosted models can be trained on a whole set of time series and used to predict every one of them in a let's just say efficient manner compared to fitting one model on each one of those. So if you think that your end goal is to perform an efficient forecasting process where you don't have to waste too much time on it, and this is all like thread that I won't open. I would just leave a lock on that one for the moment. But still, if your goal is to extract features from parallelly from a multiple time series, and then just shove them into one model, then Polar just is the perfect link to enable this plan. And that's what FunkTime did, is just to use Polars for cross-validation, estimating errors on all time series at once from a unique model. And then we re-implemented all of TSFresh, which is a really famous library for feature extraction for time series, completely in Polars. And so more than, it's also a forecasting library, of course, but it's also the perfect testimonial of what Polars can achieve. And Christopher ran the benchmarks, and he realized that, especially on the feature preprocessing side, we could achieve up to 2 orders of magnitude speedups compared to TSFresh applied on the same datasets, because Polars is excellent. And especially if you look at the literature, then you realize that you need to start applying, for example, rolling mean and averages or standard deviations with different time sizes across the same set of features. Then Polars is just the perfect candidate. And while some other projects, such as Temporian or Core Forecast, by the same folks behind Nixla, have their own data structure that is specific for time series, which makes it, of course, at times much faster, Polar still holds up. And to get back to what we were saying before, you don't need to, and you don't want to find yourself working locally with something and then working in production with something that is completely different. And because that requires a different set of skills, set of people taking care of the infrastructure, and that just distracts you and takes everything away where you should be focusing on delivering value, right? And what I really like about Polars is that it is the tool for the reasonable scale, which means it will work for 90% of the time. And when I say reasonable scale, I'm quoting Jacopo Tagliabue, which I hope is listening right now, which is an incredibly talented data scientist. I worked a lot on recommending system, and in now has a company that is working basically just a mini Databricks basically in data processing. And it was one of the strongest advocates for the reasonable scale, which means something that works for 90% of the use cases, where something that isn't something that you find on Uber's blog, and then you start thinking about it, because that's not real life. That's just the 10% of the companies, the top 500 companies in the world that need that. And if you think about it, reasonable scale needs a triumph of pragmatism. Why would you ever want to set up a Spark cluster when you can pay $3 an hour an instance of an EC2 instance on AWS, which has like 700 gigabytes of RAM? That would be more than enough for any of your data processing use cases, unless you start really creeping into the edge of that. And there are a bunch of incredible testimonials from even from Foundry, which is basically an ETL tool by Palantir, and they have their own like basically Polars engine, and they released a benchmark several months ago. I think it was still 2023, where they said yes, there are benefits of using Polars, and even if you work with 1 terabyte or in the other like of some terabytes of data, if you need to perform simple aggregation, so just to join a group by or something, not something too complex, you'd still be better off using Polars compared to Spark. So the boundary, the beauty about Polars is that it will work both in experimentation and production, shortening the development cycle, and it will work up to several hundred gigabytes of data for you. And this puts the ceiling just so much higher compared to what you could do before.
Yeah, that's. I think that's actually the best point for this library. Like this what you were saying about reasonable scale is really resonating, because it's something that works on a very big range of use cases. And it's super interesting to have this conversation. And unfortunately, I see that we are running almost out of time. I would have liked to spend even longer chatting about this kind of aspects. And maybe first of all, if any of the viewers have any questions, I would really recommend writing to mostly Luca, because he's the expert. You can write to me, but I want to probably give you the same good answers as Luca would. And so feel free to reach out offline. Maybe I would just close asking your opinion about if one wanted to contribute to Polars, to join the community. What would you recommend?
So jump on the Discord. It's online, so you can find it. They're really welcoming. Jump to the issue page on Polars. You will have the good first issue or good for the first contributors, and you will find there is a lot you can do in terms of example and documentation. That's the best way to get started with, especially because contributing itself might be a bit harder sometimes, because there is the Rust engine, so it's just you have to know Rust, but it's not just Rust, right? There is also a lot of Python in there. So there is a lot of work for Pythonistas. But the best way to get started, and I think the best way to get started contributing to a project, is just to start by documentation, because you have to learn how to relate and work with maintainers, learn their workflow, how they comment, how intensive is the review process, how demanding is the CI procedure, for example, and how many runs happen. And one thing that happens ever so often with Rust projects is that you have to compile, which is something that us Pythonistas are used to. So maybe you need to compile, maybe you just do a change in the Polars thing, and then you have to compile it again. And that takes a bit of time. It's okay, but still, that's a different workflow. So you should always get started by the documentation and refactoring issue. But the biggest value that you can bring to a project is just to make the documentation more extensible. I was actually reading a quote from Jason Liu, which is the maker of the Instructure library, which is a library for structured output generation with LLMs. And it basically is a thin wrapper around basically Pydantic. And he was saying something along the lines of, it's just 400 lines of Python code and 30,000 lines of Markdown, because the work that he did was just on the documentation. And Instruction is really popular. And I think it went beyond 1 million downloads for that. And it's a great tool that you could use, especially because it's incredibly accessible because of all the documentation there is.
Yeah, that's really true. And I've been told there's time for one question that we received from the public.
Mm-hmm.
I have a doubt regarding score. Do you see the question, Luca?
Yes, score improvement. Multiple detection anomalies. Okay, this is a question about clustering, I guess. So might not be super related to what we're doing now.
Also to computer vision, VG.
Yes, VG16. Not my cup of tea, unfortunately.
Yeah, mine neither. I'm afraid we are not able to properly answer this question. But if anybody in the public is feeling like answering this question, you see the name you can reach on LinkedIn.
Please do. I will try to get in touch with somebody that knows how to do it. But I also think there is another question from the public that we might be able to answer. Is it possible to extract data from a SQL database? Mostly yes. And in a way, you could always do that with basically any cursor object. And Polars has basically a data frame method that is called, I think, Polars read database or something that returns a data frame, which can accept any, I don't know, SQL Alchemy engine. But what you might want to do is to actually use an engine that is called ADBC. ADBC is the Arrow Database Connectivity something. Basically, it's JDBC but written on Arrow, and that's an incredibly fast engine that basically transfers the data across the network, so basically across the wire, as a columnar data. And maybe we don't have time to delve into this. Maybe we'll do a follow-up on the technicalities of Polars. But if you look into an ADBC connector, that will make it even faster because it's just transferring the data in a more compact way. That's the same representation than Arrow does. So you will push down, I think it will also push down some of the operations on the database as well. I'm not really sure about that, but definitely all the data transfer will be much, much faster because Polars just immediately receives columnar data that's basically the same memory representation that it uses. So it doesn't have to perform an additional transformation to get the data into the shape that it wants, that every Arrow object wants.
Great. I don't know if there is any other question. I don't see anything else popping up. Then it means that it's time to say goodbye. And I want to really thank Luca for joining us today and for sharing his expertise on the topic, which is really valuable, and we appreciate a lot. So thank you, Luca. And feel free to reach out to both of us about Polars or the projects we mentioned during this conversation. I hope you enjoyed as much as I did. So thank you all, and have a nice rest of the week.
Thank you, Luca. It was an incredible pleasure to be here. Thank you, everybody who attended. Please feel free to reach out. I'm always going around for conferences, so feel free to bump into me. Have a good evening. Grazie,
Bye.
Luca.